Problem 3. When the World Wide Web first became popular in the 1990s, download speeds reached a maximum of about 56 kilobits per second. Approximately how many minutes would the download of a 4.2 megabyte song have taken at that speed? Note that there are 8,000 kilobits in a megabyte. So here we're hit with many different rates and many different units. Now let's write this all down and go through them bit by bit. So we know that the speed, the rate, is 56 kilobits per second. And here we have to highlight or circle minutes because when we're answering the question, it has to be something minutes. Now we're going to look at 4.2 megabyte song. And we know that there are 8,000 kilobits in a megabyte. So let's first convert these two things. We know that there is a 4.2 megabyte and that there are the 8,000 kilobits in a megabyte. But what is the equation that we have to do? Here we have the total amount. So this is the total amount. Usually this could be equal to distance is equal to speed times time. Here this would be our almost distance, the total amount of volume that we want to cover. This would be our speed, the speed at which this is downloaded. But now we're trying to find the time, right? How many minutes? So since we already know the distance and the speed, we have to divide in order to find the time. So we're going to move this down and divide. But how can we divide this? Well, we know that 4.2 megabytes is the same as 4.2 times 8,000 kilobits. So we need to do this math. So we know that 1, 2, 3, so we move the decimal point to the right 3 times. 1, 2, 3 to do 4,200. 4,200 times 8 is equal to 33,600. So this would become 33,600 kilobits divided by 56 kilobits per second. So what is 33,600 divided by 56? Well, we could just slowly do the math here. So when doing long problems like this, I know that they must have common factors. So what I do is I start by dividing the top and the bottom by common factors. So I know 56 is divisible by 8. So that would become 7. And we divide the top by 8 as well. And that would give us 4,200. And now we see a 42 in here, so that would give us 600. And what would be our unit? Well, we know the number part is 600, but let's look at the unit parts. And this is something really cool because we can think of units as if they are numbers or variables. And I know that's a really weird concept, but I'm just saying like that to make it easier to understand. For example, we have kilobits right here. We are dividing that by the fraction kb over seconds, right? And we know that we have to flip a fraction in order to solve it. So we have to do kb times the reciprocal, seconds over kb. But the cool thing here is these two kb's, they cancel out, leaving us left with seconds. So the unit here would be seconds. So this is a really, really cool method that when you're confused with so many different units, just think about it as if it were a number and do the normal steps you would if it was a number itself. And oftentimes things will cancel out and you'll be left with 600 seconds. And a lot of times, this also makes sense, right? We're trying to find a time. So obviously the unit would be a time unit, a unit that measures time. But again, the circled word here, how many minutes? So we would have to divide seconds by 60, which would give us 10 minutes. So it would take about 10 minutes.